Hello and welcome. In this video, we're going to wrap up transformations by talking about a dilation. Our objective in this lesson is that I can identify and perform a dilation of a figure on a coordinate plane. So let's go ahead and jump in. Okay, let's start by defining what a dilation is. A dilation is a transformation in which a figure is enlarged or reduced with respect to some fixed point, C, which we call the center of dilation, by some given scale factor, which we will use the letter K for. So if I was to write one word to represent dilation, I would write the word size. A dilation is a change in size. So we're enlarging or reducing every coordinate by the same scale factor about that point, the center of dilation. So we're changing the size. What this also means is that a dilation is the first transformation we've talked about that is not rigid motion because it does not maintain shape and size. In fact, its whole objective is to change the size of a figure. When our scale factor is greater than 1, that means our shape, our object, our coordinate, our point is going to be enlarged. And when it is between 0 and 1, our scale factor, we're going to have a reduction. So the basic idea for calculating a dilation is that we're going to take all of our points, x and y, and we're going to multiply them all by that scale factor to find our new coordinate, x and y. And that's really all we're going to be focusing on. Each coordinate, the x value and the y value, will be multiplied by a given scale factor. If we aren't given the scale factor, what we would do to find it is we would divide the new length, the length from the point that we're dilating about, that point C, to the edge of our shape or to our new coordinate, divided by the length to the original coordinate. So the length to P prime over the length of P, the new divided by the old. Or if we were looking at a specific part of a coordinate, the x prime, the image length, divided by the original x value. So now that we have talked about this, let's look at some examples where we need to find the scale factor and then some examples where we need to perform a dilation. All right, for these first two examples, we are going to identify the scale factor and tell whether it is a reduction or an enlargement. Tell whether it's a reduction or an enlargement. So the first thing I want to do is identify the new and the old. So I'm going to use purple for the new, the P prime. That is associated with this length because we can see our point C here. So the new is our P prime. The old, or the original, is our P, and we can see in the picture that the original length was 8. So first of all, to go from this safety pin to this safety pin, we are getting bigger, and that is called an enlargement. And then to find our scale factor, we're going to take our new length, and we're going to divide it by our old length. And then as always, we're going to simplify our fractions. We can divide both 12 and 8 by 4, which is going to give us 3 over 2. Notice this number is greater than 1, which makes sense since we learned that if our scalar is greater than 1, we have an enlargement. Why don't you go ahead and pause the video, identify your new P, your P prime, and your old P, and see if you can determine if this is a reduction or an enlargement, and find the scale factor. And then unpause the video and see how you did. All right, our original figure is this larger paperclip, which means if we are getting smaller, that would be a reduction. And then to find our scalar, we're going to take the new length, which is 18, and we're going to divide that by the original length, which is 30. And as always, we're going to simplify our fractions. These are both divisible by 6. When we divide by 6, that's going to give us 3 over 5. And this scalar should be less than 1 because we are reducing the size of our figure. Now that we've looked at scale factor and enlargement versus reduction, let's go ahead and look at some examples that involve performing these dilations. Okay, for numbers 3 and 4, we're going to be given an original shape, and we're going to perform the dilation with an indicated scale factor. So before I begin, I'm going to just go ahead and plot the points for both of these problems. On number 3, I'm going to have a triangle. On number 4, I'm going to have a quadrilateral. So I'm going to go ahead and plot those points. All right, now that I have my original figures, let's go ahead and look at our dilations. So we are going to dilate by a scale factor of 2. That means we're going to be looking at an enlargement. We should be getting bigger. So if I take each of my x coordinates and I multiply them by 2, 2 times 2, 1 times 2, I'm going to get that a prime is 4, 1. If I take both of my b values, the x coordinate and the y coordinate, and I multiply them by 2, I'm going to get 8, 2. If I take each of my c coordinates and I multiply them by 2, I'm going to get 8, negative 2. And then I can go ahead and plot those 3 points to find my new enlarged shape. And there I have my enlargement. For number 4, we have this quadrilateral. It almost looks like an actual kite, like let's go fly a kite. And it's being dilated by a scale factor of 1/3. This is less than 1, so this is going to be a reduction. And just as a reminder, multiplying a number by 1/3 is the same thing as dividing by 3. So if I say that negative 3 times 1/3, that's the same as saying negative 3 divided by 3, which is going to be negative 1. 6 times 1/3 is going to be the same thing as saying 6 divided by 3, which is 2. 0 divided by anything besides itself, 0 divided by a number that's not 0 is going to be 0. 6 divided by 3 is 2. Go ahead and pause the video and find the coordinates for m prime and n prime and plot those 4 points. All right, m prime is going to be 1, 1. N prime is going to be negative 1, negative 1. And then I'm going to go ahead and plot the points. And there I have my reduction. So we've seen an example of both types of dilations now, an enlargement and a reduction, and we've identified scale factor. The only thing we haven't really talked about in this video is what happens if we actually have a scale factor that is a negative number. So let's look at one last example and then we'll wrap up these notes. Okay, so first thing, let's go ahead and graph the coordinates for FGH. And I'm going to list the points out, so pause the video if you need more time to graph and list. Now we are going to multiply by a scale factor of negative 1, and our ultimate goal is just to figure out what does that mean. We talked about enlargement being greater than 1 and reduction being between 0 and 1, but what happens if I multiply by a negative number? So the coordinates of all my points are just going to change signs. So f prime is going to become positive 4, 2. G prime is going to become 2, negative 4. H prime is going to become 2, 2. Let's see what happens when we graph that. So this doesn't actually look like a dilation at all. It kind of looks like it's rotated in some way, but it looks like exactly the same shape. It actually, what it has done is it has rotated 180 degrees. So what that means is when we multiply by a scale factor that's negative, not only are we going to be reducing and enlarging depending on what the number is, but we're also going to be rotating our figure 180 degrees. So this is what it might look like actually to have a composition that involves a dilation and a rotation. I don't want you to worry too much about that. It was just a little seed that I wanted to plant. So let's go ahead and wrap up this video. All right, in this video, we focused on dilations. We talked about enlarging and reducing a figure based on an indicated scale factor about a fixed point. We identified the scale factor given an example of an enlargement or a reduction, and we performed a dilation on an indicated figure. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.